Alright, hello everyone. Today I'm going to go through something called the right-hand rule that is used to solve the directions of i's, j's, k's, other than in the way that the Khan Academy video that you should have watched by now shows you. Alright, so other than the matrix, there is another way, and it is physical in the sense that the vectors actually stand for specific directions, and how it relates to the idea that a cross product deals with right angles. So if you watch the Khan Academy video, you see that this value, the cross product, is the same as the algebraic multiplication, the product of A times B, times the sine of the angle that is in between them. Okay. So if you have two vectors, vector A and vector B, and they're both pointing in the same direction, the angle in between them is equal to 0. So when you multiply the values of AB and sine of 0, you get a vector that is equal to 0. So the resultant of these two vectors is 0. In order to get the maximum, you would have to have vector A and vector B at an angle that is at 90 degrees to each other. That's where you can get the maximum resultant from a cross product. Right? Because the sine of 90 is 1, you just get whatever A times B is. If there's any angle in between, you're just really getting a fraction of what the maximum would be. All right. So we are going to define these i's, j's, k's in terms of directions we already know. So this way on the page and this way are going to be our standard. Hey, this is our positive x, negative y. Oh, sorry, negative x, negative y, positive y. Now, the I, j, k just stand for x's and y's. So the positive x is the positive I direction. The negative x axis is the negative I direction. Negative y is negative j. Positive y, positive j. But there's the third dimension, which is going to be coming into or out of the paper. All right, I'm going to draw that as a dotted line. And we're going to say that this one right here is pointing out of the paper. All right, so that would be the vertical. And this is going to be the positive z-axis or the positive k-axis. This one will be the negative z or negative k. Okay, remember the z is perpendicular to the table. So to solve this cross product of A and B, we're going to write it out in an algebraic type of form. 5i minus 6j plus 3k crossed negative 2i plus 7j plus 4k. Okay, and now we really just multiply by just distributing each one across each other. Okay, so I already went over this, where we have two vectors that are pointing in the same direction, and in this case it's in the x direction or positive I, so we have an I dot an I, or I cross an I, where the angle in between them is 0. So if we take 5i cross negative 2i, we're going to get a value of 0 for those. Alright, so we did this one. Now we're going to take 5i cross 7j. So the numbers, the magnitudes, just get multiplied together. And that will be plus 35. Now we have to figure out what the direction of the vector is going to be. Now to do that, you have to use the right-hand rule, where we position our hand so that our fingers kind of create the three axes. Right? So you have your first finger, second finger, thumb, and they have to be locked so that they're all at right angles to each other. So my thumb and first finger is at a right angle, my first finger and second fingers trying to make a right angle, and then my middle finger and thumb, how am I doing that? Here. also make a right angle. Okay. So what we have to do is follow this, where the first vector is the first finger, the second vector is your second finger, and the resultant is your thumb. So it always has to go in that order. So if the I vector is first, that's where you point your first finger. If the J vector is second, that's where you point your second finger. So let's follow along with this. So 5I, so I have to point my finger in I, and then my finger's locked in that orientation. I cannot change that. I can just rotate along that axis. So I have to turn so that my second finger is pointing in the J direction, which is up here, and then my thumb is going to point in the direction of the product, which is out of the page, or the positive K. So this is going to be 35 times a positive K. All right, now that's this times this. Now we're going to do 5I cross K. So we're going to add 5 times 4 is 20. And now we have to figure out the resultant direction. So this is a negative value. No, this is the positive value, so it's positive I. And then K is up because it's positive. So I have to turn so my second finger is up. And then you look at where your thumb points, it's pointing down on the page, which is the negative J. So you can say times negative J, but the negative just makes the entire value a negative right there. So now I've crossed each of those values. Now I got to take this negative 6 and cross it across those three. All right, so here we have a negative 6J times a negative 2I, so the 6 times 2 is 12. And now I have to cross J and I. So it's a negative J, so that's this is the first vector, so it has to be my first finger. So my negative J is this way, and again I'm locked in that orientation. I can only rotate, and I have to point my second finger in negative I. So I really have to turn my hand around, okay, so that my first vector is still down, and my second vector is pointing at negative I. You can't see my thumb because it's touching the desk. It's pointing into the page. So that means that that is a negative K. Alright, so that's the J cross the I. J cross J is 0. And now we have the J cross the K. You can do the multiplication, which is 24. Now we have to do the vectors, negative J cross K. Negative J is downward on the page. K is up on the page. Alright, and it's hard to get my hand in the camera here. And you can see that my thumb is pointing in the negative I direction. Alright, it's pointing this way. And that's a negative I. Alright, now we just have our last one, the cross. I'm going to continue down here. So we have 3K times negative 2I. The 3 times the 2 is 6. And we have K cross negative I. So this is the first vector, so I have to point my finger at the K, and then my second finger at negative I, right? So up is the K, second finger is at I, and my thumb, I can't get my hand underneath there, is pointing down this way on the page in a negative J. Alright, 3K times 7J, so that's going to be plus 21. K cross positive J, so K is this way, positive J is this way. I have my thumb pointing at negative I. And then K cross K is 0. And now you just do the addition. Alright, so let's find our I's. So here we have negative 24 and negative 21. So 24 plus 21 is 45. It's negative I. Now, Khan Academy had that wrong actually on their video. Hopefully you saw that. Now we do the K's. So K here, oh sorry, J's. J here, J here. So we have negative 26 J. And now we do the K's. 35 minus 12 is positive 23 K. And that is the value of the product of A cross B. We are going to use the right-hand rule a lot, especially during E and M. All right, so at least make the connection with how do we determine the resultant vector direction, the idea that your right hand has to be used and locked into a three-dimensional axis that you can only manipulate by twisting and turning your wrist, but never moving your fingers. All right, we're going to get a lot more practice on that throughout the year.